The human eye, often called the window to the soul. But did you know it's also a mirror to ourselves? Our eyes don't just see the outside world, they also offer glimpses into their own inner workings. It's like having a hidden universe right inside our own bodies. Let's embark on a journey to unlock these secrets. We can witness this hidden world through everyday phenomena, fleeting shapes, strange patterns. These aren't glitches in the matrix. They're opportunities to understand the amazing machinery of sight. Our eyes are more than just passive receivers of light. They are active participants in how we perceive reality, and within their structure lies a fascinating story waiting to be told. Prepare to be amazed. The journey inward is just as awe-inspiring as gazing at the vastness of the cosmos. Have you ever noticed tiny specks or strands drifting across your vision? These are called floaters. They can appear as small dots, thread-like strands, or even cobweb-like shapes that seem to move as you shift your gaze. Floaters are a common phenomenon and can be quite intriguing once you start paying attention to them. Don't worry, they're usually harmless. Most people experience floaters at some point in their lives, and they often become more noticeable as we age. While they can be a bit annoying, they typically don't interfere with your vision significantly. Floaters are actually shadows cast by tiny bits of debris floating in the vitreous humor. This debris can be made up of various substances, including microscopic fibers, clumps of protein, or even remnants of the eye's development. When light enters your eye, it passes through the vitreous humor, and these tiny particles cast shadows on the retina, creating the appearance of floaters. Think of the vitreous humor like a clear, jelly-like substance filling your eyeball. This gel-like material is crucial for maintaining the eye's shape and providing a pathway for light to reach the retina. It's mostly composed of water, but it also contains collagen fibers and proteins that give it its jelly-like consistency. It helps maintain the eye's shape. The vitreous humor is essential for keeping the eyeball round and properly inflated, ensuring that the light entering the eye is focused correctly onto the retina. Without it, our vision would be significantly impaired. As we age, this jelly can become more liquid. The vitreous humor undergoes changes over time, gradually becoming less gel-like and more liquid. This process, known as vitreous senescence, is a normal part of aging and can lead to the formation of floaters as the collagen fibers within the vitreous humor clump together. Small fibers or clumps of protein can form within it. These clumps can vary in size and shape, and they can move around within the vitreous humor as you move your eyes. The movement of these clumps is what causes floaters to appear to drift across your field of vision. These imperfections cast shadows on the retina, the light-sensitive lining at the back of your eye. The retina is responsible for converting light into electrical signals that are sent to the brain, allowing us to see. When floaters cast shadows on the retina, they create the visual effect that we perceive as floaters. That's why you see floaters. They are essentially the shadows of these tiny particles within the vitreous humor. The appearance of floaters can vary depending on the size, shape, and location of the debris within the eye. They seem to move with your gaze because they're floating in the vitreous humor. When you move your eyes, the floaters move too, but with a slight delay. This is because they are suspended in the gel-like substance and take a moment to catch up with the movement of your eye. Most of the time, floaters are nothing to worry about. They are a normal part of the aging process and usually don't require any treatment. However, it's important to be aware of any changes in your vision, and to seek medical advice if you notice anything unusual. But a sudden increase in floaters, especially if accompanied by flashes of light, could signal a problem. This could be a sign of a more serious condition, such as a retinal tear or detachment, which requires immediate medical attention. It's best to get your eyes checked. Regular eye exams can help detect any potential issues early on and ensure that your eyes remain healthy. If you experience any sudden changes in your vision, don't hesitate to contact an eye care professional for advice and treatment. Ever rubbed your eyes and seen fleeting stars or flashes of light? That's a phenomenon called Phosphenes. These bursts of light aren't coming from the outside world. They're created by mechanical stimulation of the cells in your retina. Remember, the retina is where light signals are converted into electrical signals for your brain to interpret. When you rub your eyes, you're putting pressure on the retina. This pressure can activate the light-sensitive cells. The brain interprets these signals as flashes of light, even though no actual light has entered the eye. Phosphenes demonstrate the amazing connection between your eyes and your brain. It's a reminder that what we see is ultimately interpreted by the brain. The next time you see stars without looking up at the night sky, remember the amazing interplay of your eyes and brain. Section 4. Blue Field Phenomenon, a microscopic light show. Have you ever gazed up at the sky on a clear sunny day and noticed tiny bright dots darting across your field of vision? This fascinating occurrence is known as the blue field entoptic phenomenon, and it offers a unique glimpse into the microscopic world within our own bodies. The blue field entoptic phenomenon is a truly remarkable sight. It allows us to see the movement of our own white blood cells as they travel through the capillaries in front of our retinas. These capillaries are the tiniest blood vessels in our bodies, and they play a crucial role in our circulatory system. To experience this phenomenon, simply stare at a clear blue sky on a sunny day. The bright uniform background of the sky provides the perfect contrast for observing the tiny bright dots that move quickly across your vision. Notice tiny bright dots moving quickly across your vision? These dots are actually your white blood cells, which are larger than red blood cells, and reflect light differently. As they move through the capillaries in front of your retina, they create the appearance of bright moving dots. Those are your white blood cells. White blood cells are an essential part of your immune system, helping to protect your body from infections and diseases. They are larger than red blood cells and have a different structure, which causes them to reflect light in a unique way. This phenomenon occurs because light is passing through the capillaries in front of your retina. The retina is the light-sensitive layer at the back of your eye that captures visual information and sends it to your brain. When light passes through the capillaries, it illuminates the white blood cells, making them visible as bright dots. Capillaries are the tiniest blood vessels in your body. They are so small that red blood cells sometimes have to squeeze through single file. This allows for the efficient exchange of oxygen, nutrients, and waste products between your blood and tissues. They're so small that red blood cells sometimes have to squeeze through single file. This process ensures that every cell in your body receives the oxygen and nutrients it needs to function properly. White blood cells are larger and reflect light differently. Unlike red blood cells, which are primarily responsible for carrying oxygen, white blood cells are part of your immune system. They help to identify and destroy harmful pathogens, such as bacteria and viruses. When light hits these white blood cells as they flow through the capillaries in your eye, you perceive them as bright dots moving across a blue background. This is because the white blood cells scatter the light, creating the illusion of tiny moving points of light. It's like watching a microscopic light show. This phenomenon provides a unique and fascinating glimpse into the usually invisible world of your own circulatory system. By observing the movement of your white blood cells, you can gain a better understanding of the complex and intricate processes that keep your body functioning. This phenomenon provides a glimpse into the usually invisible world of your own circulatory system. It reminds us of the incredible complexity and beauty of the human body, and the many intricate processes that work together to keep us healthy and alive. So next time you find yourself staring up at a clear blue sky, take a moment to appreciate the microscopic light show happening right before your eyes. Section 5. The Purkinje tree, a branching network in our eyes. The Purkinje tree, or Purkinje effect, reveals the intricate network of blood vessels in your retina. This fascinating phenomenon is named after the Czech anatomist Jan Evangelista Purkinje, who first described it in the 19th century. The Purkinje tree is not something we see in our everyday lives, but with a simple trick. You can observe this hidden network within your own eyes. But it requires a bit of a trick to see. The Purkinje tree is not visible under normal lighting conditions because our eyes are adapted to filter out these internal structures. However, with the right conditions, you can catch a glimpse of this hidden network. Stand in a darkened room and ask a friend to shine a pen light into your eye from the side. The darkness helps your pupils dilate, making it easier to see the subtle shadows cast by the blood vessels. Don't look directly at the light but rather off to the side. This angle allows the light to enter your eye in such a way that it casts shadows of the blood vessels onto the retina. You might notice a shadowy branching pattern in your vision. That's the Purkinje tree. These shadows are the silhouettes of the blood vessels that supply your retina with essential nutrients and oxygen. It's essentially the shadow of your retinal blood vessels, projected onto the less light-sensitive part of your retina. This part of the retina is not as adept at processing light, which is why the shadows become visible. Normally, we don't see our retinal blood vessels because they lie in front of the light-sensitive cells. These cells, known as photoreceptors, are responsible for converting light into the electrical signals that our brain interprets as vision. But by illuminating the eye from the side, we cast their shadows onto a different part of the retina, making them visible. This side illumination technique disrupts the usual filtering process, allowing us to see the otherwise hidden blood vessels. It's like seeing the hidden plumbing of your eye. Just as plumbing carries water throughout a building, these blood vessels carry vital nutrients and oxygen throughout your eye. This network is crucial for maintaining the health and function of your retina, ensuring that you can see the world around you clearly. John Evangelista Purkinje's discovery of this phenomenon was a significant milestone in the field of anatomy and vision science. His work laid the foundation for our understanding of the complex structures within the eye and how they contribute to our ability to see. Today, researchers continue to study the Purkinje tree and other aspects of retinal anatomy to develop new treatments for eye diseases and improve our understanding of vision. The Purkinje tree is not just a fascinating visual trick. It also provides valuable insights into the inner workings of our eyes. So next time you're in a dark room with a pen light handy, give it a try. You might be surprised by what you see. The Purkinje tree is a reminder of the incredible complexity and beauty of our eyes, and the hidden wonders that lie just beneath the surface of our everyday vision.